36. Let's see. Whoa, it's very zoomed in. Very much. 36. Is the one about the books?
Yes.
Yes, okay. Well, first question I have for you is, have you guys, anybody looked up to see what sample space means? Or do you just go off of what I say? Because me plus book equals class. So, sample space, anybody know what sample space is?
It's the like the number of books represented. So like it says.
No. I'm sorry.
Okay.
Sample size would be the number of things.
Right, but like this would be like F1.
Beautiful. I love it. So sample space, it's not final space. Sample space is the collection of everything that could happen. So if I was picking one card from a deck of cards, the sample space would be big. Right? It'd be the ace of diamonds, the two of diamonds, the three of diamonds, all the way, and then just keep listing everything that could happen. Are you guys with me? Okay. So in this problem, you have 8 fiction books, and the rest are nonfiction. So you got 4 nonfiction. The fiction books are numbered 1 to 8, very creative titles, and the nonfiction are 1 to 4. Right? You with me? So I think you kind of gave away a great way to represent these things. What would you call the fiction book that's titled 1? What symbol would you give it F1? So the sample space would be F1, comma, F2. And you got 8 of those, right?
Yes.
And then maybe for nonfiction, you'd be crazy and use N. Oh my God. So then the nonfiction would be N1 through N4. So that would be, the sample space should have a size of 12, but what's in the sample space is a representation of all the things that could happen. I like it. Coolness. I think I know what happened there. Somebody had torn the little thermostats off the wall because I don't think I could turn them off. So I think they tore them out because it was getting so hot in here. So let me know, is it getting warm? You guys all right? It's getting a little warm? All right, let's play. Okay, I definitely feel warm. Hi. That's what happened, yeah. Not simple enough. Yeah. Turn off. All right. There you go.
Should you put it in like braces or brackets?
Yeah, it's kind of like what's called
brace.
set notation.
Yeah.
So you would do it like this, F1.
Okay.
Yeah. Comma, keep going.
Got it.
Right. So if you had a red marble, a blue marble, and a green marble in a bag, and I picked 2 of them, my sample space would be red, 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 blue. Do you guys see what I'm saying?
Right.
Red, green, so forth. So it's everything that could possibly happen given what you're doing. Beautiful. I like it. Okay, I like it. Anything else from homework stuff? So I know that one's a weird one when you first read it. Yeah.
41 from 3.2.
Spoo. So the mistake people make, this one in here, right? The mistake people make on all of these here, first off, did I talk about mutually exclusive? Did I talked about independent,
Yes.
for damn sure. But I don't think I talked about mutually exclusive. I like it. So it's a really good question. Because, yes?
Would you like to write this in our notebook or just on the homework paper?
Say again, sorry.
Would you like us to write this stuff in our notebook or maybe on just the homework paper? Or either?
Notes?
Yeah.
You can put them wherever you want to. Some people don't put them anywhere, and they're crazy. If I were you, I'd put them in a notebook or something. Keep it all organized. All right. What's the word exclusive? When I say exclusive, especially if I say it like this, exclusive. What does that mean? What do you see in your head when I say that word? Exclusive. Say again?
Only like one way to
Okay.
obtain
I'm with you. Expensive, I like it. So exclude, of course, means to not let certain elements in. So exclusive means it only lets certain things in. So it excludes something, right? Sort of like that bar with this evil bouncer
Right.
would be excluding me.
Right.
You with me? I like it. So are you with me? Mutually means that you do that together. So mutually exclusive means not only does the club not let me in, I don't want to go in the club. I exclude them. I'm like, you can't come in my house either. And they're like, I didn't want to do that. I don't care. I'm going to pretend like that makes me feel better. You guys, so mutually exclusive would be something like rock and ice cream. Is there anything that is truly both? Can you have something, pick it up and it's rock, and it is ice cream? Can that happen? No, and I don't care about ice cream that looks like a rock. I don't care about a rock that's got some ice cream on it. You ain't gonna lick that rock, hopefully. Right? The rock is not ice cream. So the idea of rock and ice cream are mutually exclusive ideas because you can't be both. Yes? I like it. So, if I tell you that A and B are mutually exclusive events, what's the probability of A and B?
0.
Yes. So when you look at like number 40, what can you write down immediately? This first sentence, a lot of people just fly past it. People are like, that's a bunch of words. Where's my number so I can do shit? But that first sentence is the most important thing in this problem. What can I write down immediately from this first sentence in number 40? E and F are mutually exclusive. What does that mean? The probability of E and F is 0. And what is the formula for this guy? That's what that is. What's the formula for it? You can look it up. So I'm always curious if anybody's like, I got a formula for A given B. Well, then that means you got a formula for E given F, right? They're just variables. I can just replace them. So who's got their formula for A given B?
It's the probability of A and B over the probability of B.
Exactly. Does that sound familiar? The given goes on the bottom, right? Remember that? So there's the formula for it. So what is the top?
0.
0. So you couldn't even do this problem if you didn't take into account what the first sentence means. You guys see what I'm saying? What about this problem? That's how they're doing this. They should be done with that. What about number 41? I like this edge of the paper thing here. J and K are independent. What does that mean? If J and K are independent events, do you know what that means? Let me start us off. That means the probability of J given K, for example, equals probability of, no, come on, no. Not the and. I'm not asking for the formula of and. I'm asking for the idea of independent. K happens. If J and K are independent, does J give a shit that K happened? No, so it stays the same. That means independent. Or, by the same token, what's this got to be? They don't give a shit about each other. J happened. Did K care? No. So what's that? This is still the probability of K. I really want you guys. So this is the probability of J given that K happened. J don't care about K. They told me they're independent. So the probability of J will not change because they told me they're independent, right? And if I ask you, are these independent, you'd have to calculate those and compare them, just like we did on that handout. I like it. So the very first thing I can do is write this, and then this is easy. If the J given K is 0.3, what's the probability of J? 0.3. There's a gimme for you. But that first sentence, people skip past it. You're not going to finish it. That first sentence gives you valuable information. They're related to ideas. You guys see that? That's going to happen in several places. Okay, I like it. Maybe. So the idea of mutually exclusive, the idea of independent, they are as important as knowing the math of stuff. Okay, maybe. Anything else from homework stuff? Y'all look properly oppressed by my mathematics. I'm used to it. I'm sorry. Okay, no other questions? You guys are good? When is chapter 3 homework due? The day of the test, really. I'm not going to change that rule, but when should you have it mostly done at least? By the day of the quiz. What's the day of the double quiz? A week from today, right? You guys with me? On the other side of that sheet that we still have to finish, right? We did this much, I think, last time, right? On the other side is a practice quiz. I don't normally give practice quizzes, but I do for this one. I will have an answer key for this Thursday, and then the quiz is going to be that following Tuesday. I like it. Try to have your chapter 3 homework done by Tuesday. That means you've done the practice, so you should do better on the quiz, but you don't have to have it all done. You still have until the day of the test, like always. All right, so let me pull that out here for a second. Let me see. So that's what we did last time. That's all up on the video if you missed last time. Missing last time, it's going to be a rough one to recover from, just to be blunt. But thankfully, I put the video up, so it should help you out a little bit. You can always come to my office too. So let me do this. To get into number 3, let's do this. And this is from my other class. Let me remind you what formulas we've got so far. Because number 3 is the only problem on here that I did not give you stuff you can count. So I said last time, this is such a weird thing to hear a math teacher say, but the formulas get in the way for a basic problem. So if I have everything I need to count, I don't need any freaking formulas. The idea of probability is very straightforward. The number that match what I'm looking for divided by the total things that could happen. I only need the formula when I have nothing to count. In number 3, did I tell you about how many people I'm talking about? Well, 4 Americans, but the probability is just 7%. I don't see like the population of Americans. I don't see them. I'm going to have to use formulas. And by the way, that is a real result from a survey about who thinks chocolate milk comes from brown cows. I will tell you this so that your faith in humanity is not completely destroyed. It was really the way they worded it on the survey. But you have to also realize that it's more than 0% that actually do think this. It's just not 7. It's probably not 7. But anything more than 0 is bad, right? Okay, so let's do this. I want to remind, let's recap what we got so far as formulas. Remember what the probability of A or B. What's or basically mean? Or basically means I love the answer. So not a synonym. Or basically means add. Let me say this like several times so you realize it's a note. Or basically means add. Or basically means add. Why does that make sense? Because the or should increase the things that match what I'm looking for. Or is the nice bouncer. More people should get in. The probability should get bigger. So I'm going to add. So this is the probability of A plus the probability of B, but why is that sometimes not good? Why do I say basically add? Because I might have to subtract any that are both, right? So if I count all the Democrats and I count all the men, could I have counted anybody twice? Yes. Yeah, the male Democrats. I got to subtract them off so I don't count them more. Okay, maybe. What does and basically mean? Multiplication. I love it. And we saw that with my silly example of getting slapped on the face and the not so silly example of the space shuttle blowing up and why that was. Okay. So this would be probably A times probably B given A. Or the probability of B times the probability of A given B. So we use that idea on number 2 on the handout. Okay, I like it. And of course, there's one more. I'm not doing in the order that we created the formulas. I'm doing sort of the order that makes sense to talk about it. Or is basically add, and is basically multiply. It's just this might change, right? This is like putting a card back in or not putting a card back in. So this could change. And then, of course, you got probably of A given B, which we wrote earlier, which is really where this formula comes from. Okay, I like it. Maybe. Okay, I like it. All right, so let's have those tucked away. So obviously, we sort of just made a formula sheet for the double quiz, right? So keep these somewhere. You can write these down on a piece of paper. I'll make sure next time when I review that these are the only things you can have on the formula sheet for the double quiz. All right, so everybody's got those? Yes?
I just have a question. Of like, if I write those on my formula sheet, am I allowed to use symbols instead of the word and or?
Oh, sure. Do you have the symbol?
Yeah.
Okay, yeah. If you know the symbol for and or, you can use them. So just in case you guys are curious, the symbol for or is?
Upside.
Yeah, no, this guy. I love this. I love that that's the symbol for it because it's kind of like you or you, somebody. Shpoop is the symbol I make. You or you, God, somebody do it, right? And then the symbol for and looks like an A that lost the bar in the middle. That's how I remember those, right? But do you have to use the symbols? No. If you know them, you want to use them, kick ass. Yes?
It can also be remembered by that you can be happy with the first one and unhappy with the second.
All right. I see. Sort of like the nice bouncer, mean bouncer idea. I like that. You're unhappy at the mean bouncer because it can't get in the bar. So that's the and. That works for me. I like it. Let's see. What is in here today? Okay. All right. Woo-hoo. That'll help me out. All right. So let's go to number 3 now that we have those formulas. We're going to need them. This is the first real problem that we kind of really needed the formulas. First thing I want to do is, in the homework, you're going to see this kind of problem. And this has got me a little concerned. Nobody's asked me about some of these questions. There's a problem about like Latino Californians and the Californians that are the death penalty. I can't remember exactly what it was. Same-sex marriage stuff. I can't remember what it was. Does that sound familiar to anybody? Right? Maybe? No? Not at all? Some of you guys are like, dude, I'm on section 2.4. Get into 3. Now, on those problems, they actually tell you the symbols to use. So look, do I tell you some stuff? Yes, I tell you that 7% of Americans think that chocolate milk comes from brown cows. How can I represent that symbolically? What letter do you want to use to mean somebody thinks chocolate milk comes from brown cows? A few different options. I like it. So let's say C, because the next thing I'm going to do is Brussels sprouts, if you guys see later. So say this means somebody thinks, you could use D for dumb or something, right? Or deficient, or I for ignorant. But C, let's use that for chocolate milk comes from brown cows. You guys with me? So what value does that have? 7%, so 0.07. I like it. Now look at the question. This is something we haven't fully done yet. It's sort of related to what we did in number 2. What's the probability that the first person, so I'm going to select 4 Americans randomly. What's the probability that the first one thinks that way, chocolate milk comes from brown cows, and the last 3 don't? So it's sort of like picking 2 people out of the haunted house. The first one is a Republican, and the second one's a Democrat. I multiply those together. You with me? But what I had to do, now watch. Here's the key. How big of a population was this? Number 2. How big was the population? 21. Is that a big population? If you had a country where that was the population, it's like, oh, that's cute. Right? It's very small. What population am I talking about in number 3?
All American.
Yeah. Anybody have any idea how many Americans there are? How many people there currently are in America?
360 million.
Roughly 360 million. I love it. And now, go with me. I'm going to show you. Okay. What I'm about to do, let me try it this way instead. Here's how you do this problem, and then I'll show you why we can do it that way. Let's see how that works. Right? I normally do it the other way around, but let me just show you directly how I can do this problem. I remember how I did this problem? There were 2, so I put 2 spots, and there was times because it was and. So now I've got 4 spots multiplying What do I want the first person to do?
Think that chocolate.
Thinks that chocolate milk comes from around house. So what value do I put here? What's the probability of that happening? 0.07. The number of people I pick cannot affect that, right? Because 7% came from the whole population, and then I'm picking a few people. It's still going to be 7%. I don't care how many people I pick. So and then the next 3 people, each of them, what do I want to be true about the next person? I want them to be rational, to not think that way. So what am I going to put in there? What's the probability that person thinks that way? 93. So then what's the next guy? This is where things get interesting. I might have just messed you up, but I didn't mean to.
Same, 93.
It's still 93. Now why, just some of you guys hesitate. What do we have to do up here? We had to change that, right? All right, so that's the part I'm going to explain to you why we don't have to here, and it must be related to the fact that I have a very large population. So this is beautiful, man. When I have a large population, I don't have to worry about freaking ratios and changing the tops and bottoms, and I'm going to show you why now. I've never actually explained it this way. I always start with the why, and then I do the what. So here's the what I do. So let's go ahead and get that. What is that? 98705 something?
Uh, 0.0563.
All right. So here's why we're allowed, Jeff. I can't leave myself much paper. Here's why we're allowed to do that. All right. So we have 360 million Americans, right? Roughly. I don't know, somewhere around there. I remember October 2008, we passed 300 million. And then we just keep on making people. So let's do this. If there were, let's do it this way. What's 7% of 360 million? Let's see how many people answered in the affirmative for brown cows make chocolate milk. Somebody help me out. What's 7% of 360 million? 7,228. So 2,280,000. Maybe? No, I'm off. I did the wrong thing. Don't worry about me. I'm trying to do my head. Give me a break. Do it again. Yeah, it's got to be 21252. Is it 252? 252 with a bunch of zeros? Yeah. So 7% of this. Does everybody see where I'm getting that from? 7% of Americans said this. So 7% of this comes out to be 252000000. Is that cool? Right? Or did I have too many zeros? I have too many zeros. You can do it, Jeff. 2520000. Is that enough zeros?
No, one more zero.
Damn! I had it right the first time. All right. 252000000. Okay. Someday I'll get it. That's 25 million people, right? Holy shit. So now watch. Stay with me. So if I had like 2 people and I said I want both of them to think this way, it would be 25, all that out of 360 million, times what happens to the next number now? Don't they both go down by 1?
Yeah.
If I pick somebody like that, I'm not going to want to pick them again. I'm going to just put them over here. Here, stand over there. I'm going to turn back to the 360 million people that I have in the room. And so now this is going to be 2519999 out of 3599999. Holy shit. Okay, what the hell is my point here? Now watch. This is 7%, right? Because that's where that came from. Help me out. Somebody figure out what this is. Put this in your calculator. Maybe I'll do it with you. If I change the top and bottom by 1, how much does the result actually change? Now, what do you guys get? 0.06?
Yeah, 0.06.
0.06? 0.06999999. All right, if you saw that, what are you going to say? 7%. You with me? Yes?
Yeah.
Maybe? Okay. So when you have a huge population, you do not have to make the ratios and change the numbers because holy shit, it basically don't change. When I had 21 people in a haunted house, I had to make the ratios because these are pretty different. That is a difference of 3% almost, which is actually big. If the unemployment rate suddenly went up by 3%, would that be news? Oh yeah, so 3% is kind of big. This, what we just did, is nothing. How different is it? It's 0.00000026 off. That is basically the same thing. Are you guys semi with me at all? So these problems are kind of beautiful because I can just use the percentages they give me directly. Okay, so that's one thing right there. Look at part B. So what does that mean? What situations match with what that question is looking for? At least one of them thinks that way. So what could be the situation that matches? You could do it. What's at least one mean?
One.
Does it just mean, say again, sorry.
Just one.
One or two or three or
All
four. Yeah, right? You guys with me? How many ways is there to have one person thinking that way? The first person thinks that way, or the second person thinks that way, or the third person, or the last person. You have to do each of those and add them because or means add. Or two people. Well, which two people? It could be the first two, I guess. So I put a 0.07, 0.07, 0.03, or the last two people, or the middle two people, or the first one and the last one, or the first one and the third one, or the holy shit, and I haven't even gotten to 3 yet. So hopefully, dear God, Jeff, first off, what the shit are you talking about? And secondly, don't tell me I've got to do that with shit. No, you don't. So watch this. Somehow this is going to relate. If the probability it's going to rain today is 1%, what's the probability it's not going to rain?
9.
If I know the opposite of what somebody wants for a probability answer, I just have to do 1 minus that. Like you just did, right? What is the opposite of at least 1? So the best way to think about it is, the opposite would be what would negate something. So if I said at least one person in here understands what I'm saying, how could you show that I'm wrong? What's the only way you could show that I'm wrong? If I said at least one person in here understands me, how can you show that I'm wrong? You have to show me that nobody understands me, right? You guys with me? And that's resonating. I can see in your eyes. You're like, yeah, that's the first thing you said. I agree with. Stay with me. All right. So what is the opposite of at least 1? None. So if I can figure out the probability of none, I can then do 1 minus that and answer that question. So it's sort of like I answer the opposite of the question, so the question gets all angry, and then do 1 minus, and it's like, oh, okay. I don't know if you guys get me. So when can you do that? Any damn time that the opposite of what a probability wants is less work, I'm going to do that. Because I can just do 1 minus what I get, and I'm done. So if I said, what's probably going to rain today? And you said, probably it's not going to rain, it's 1%. No, I want to know, okay, 1 minus that, dude. What do you want? I don't know if you guys. So, let me explain this idea of why it's the opposite in another way, and why it's 1 minus. Let's see. Someday I'll actually remember to bring more blank paper. Somebody want brownie points? You got blank paper to borrow? Oh, maybe I got a little bit. Okay, this is enough. No brownie points. This represents the situation. You guys see that? How many people out of 4 could you have? 0, 1, 2, 3, 4. Right. Let's say I know these probabilities. I'm just going to make some stuff up for right now. Okay. So 1, 1. Why are you doing that to yourself, Jeff? Sure. Let's just keep it easy. I like that idea. 7, 8. There you go. That's fine. What am I trying to make sure happens there, by the way? adds to 1. I love it, right? And I think I achieved that. I hope. I don't know. We'll see. If I said, what is the probability that at least 1 from this? That would mean these things, right? I would have to add these up. Couldn't I instead just do 1 minus this? What do the probabilities add up to be? 1. So 1 minus any chunk of this has to equal the other chunk because they together make 1. Yes? So if they want the probability at least 1, the opposite is the stuff it leaves out. And it only leaves out one thing. Okay. I like it. You guys don't like it, but that's all right. How much have we worked with that yet? Like less than a minute. So, okay. So let's see how the hell to do this. So what I'm going to do is I'm going to figure out the opposite of what the question wants. Right? And anger it for a minute. It's like, I didn't ask it. So I'm going to figure out what the probability that none of them think that way. Because that's easy. If none of them think that way, what goes into each spot? None of them think that chocolate milk comes from brown cows. 0.93, right? Because if I do this directly, I'd have to do 1 would be 0.07, could be in any of the 4 spots, and then I need 2 0.07s for 2 people, and then I need 3 0.07s. Oh my God, that's a lot of work. I don't know if you guys see what I'm saying. In fact, let me do this. You know, just do what you want to, Jeff. All right. If I say, what did I say? Chocolate milk, and this would be not chocolate milk, right? They don't think that way. I think the book uses, by the way, the book uses this symbol to mean not. A little prime, dude. I don't like that. I'm going to do this without thinking about it, so that's what I use for not. So now watch. If I want one person to think that way, wouldn't it be like this is one way to do it, right? Or this, do you guys see what I'm doing? And you're writing a bunch of C's down, Jeff. But if I want one person to think chocolate milk comes from brown cows, it could be the first guy, and the other 3 don't. Or it could be the second guy, right? So you have to do the probability of this, plus the probability of this. Or it could be the third guy, or it could be the last guy. All right, that's for 1. At least 1 means 2. Oh, shit. Or it could be the first 2.